Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on PVTP software for fluid modeling, especially in this series of video. We are dealing with compositional oil modeling. Okay, so before doing the regression as the ultimate step for fluid modeling, okay, for all these exercises, okay, we are still in the process of checking the quality of the match for CCE, for differential liberation, and for this specific video for separator experiment. Okay, in previous video, we are dealing with the differential liberation. Now, go to this separator train. Okay, the separator object already exists in our calculation window as this was created earlier during the earlier step. Okay, so we double click on this to open the window here, and you see we have two pressure and one temperature from 80 psi to 0 psi. We can click on calculate and go to results table. Here we have pseudo properties and surface results. This is the surface results, please note. Okay, the properties you can see. Now let's go to the stage results. All right, let me expand this. And let's focus first on the stage GOR, especially the first stage. It's 668.893, whereas for the oil density from the EOS, from our model, is 820. Okay, so this is already, it compares very well with the reported value, with the lab value, which is 814.5 kilogram per meter cube, whereas the calculated GOR is 669, also compares very well to the reported value, which is 661. Okay, so in summary, the equation of state, our current fluid model currently provides an adequate description of most of the fluid properties, right? By the fluid properties here, I mean the liquid density and the GOR from the separator experiment, and the liquid density and viscosity above saturation from CCE, and also the GOR and oil formation volume factor from differential liberation. However, you know that we still have room to improve the quality of the match, especially for, for differential liberation, we only produce the trend. We can follow the trend for the GOR, for the density, for the formation volume factor, but for the exact value, the match is poor, I can say. The trend is good, but the exact value, the quality of the match is poor. Okay, so we have checked the CCE, okay, the CCE and the differential liberation, okay, and you see still not very good, and the separator train is good. So after, checking the current quality of the match for the CCE, differential liberation and separator train, now we can take a moment to consider all of these outcomes and what steps need to be developed for the regression strategy. Okay, regression, it's not just using the software, clicking here and there, but you need strategy to, to improve the match. You can keep the quality of the match for the separator train, but you can focus your attention, focus your regression strategy to deal with the CCE and differential liberation, because those two have poor matching for the exact value. Okay, as a best practice, you can do some of these things. First, you can create a list of the current objective and you can rank the objective in order of declining importance. Like, for example, the most important thing for the regression is to get the saturated liquid density. That's the most important thing to match, because the current matching is not very good. And then you also need to improve the matching. This is important for the saturated oil viscosity. And then, of course, saturation pressure, and then GOR. And I'm not saying that this is not important, but the least important for our upcoming regression is the standard condition density, because we currently already have, relatively speaking, good matching. Okay, so that's the first strategy. You create a list of objective and then rank the objective. By objective here, I mean the parameter to improve. You rank them in order of declining importance. And then you consider what pseudo properties affect each of these objective, each of this parameter, and by how much. Okay, how does the parameter X change by changing pseudo properties Y? Okay, so that's very important. And then you consider how changing the selected properties for regression affect other objectives. And then you consider which parameter will be more difficult to readjust at a later stage, and thus decide on suitable anchor point. Okay, so that's sort of the strategy that we can do. You can read more by reading the manual from PVTP for the best practice for the regression. But I think so far we have done relatively good steps for the entire exercise. Okay, we have completed the checking for the separator train, CCE, and D-flip. In the next video, we will do the regression. Okay, until then, stay healthy and thank you.